In this video lecture, I will explain the laws of logic. So there are several laws. One by one we will discuss all the laws, and these laws can be verified using truth table. So let's see the first law. Law of double negation. Law of double negation says double negation of P is equivalent to P. So we'll see if I have proposition P, so input will be 0 and 1. So negation of P will be 1 0 and double negation of P will be again 0 and 1. So you can see here P is 0 1 and double negation of P also is 0 1. So they are logically equivalent. Now the second law is De Morgan's law. So De Morgan's law, it says negation of P or Q is equivalent to negation of P and negation of Q. So we'll see P and Q. So inputs are 0 0, 0 1, 1 0 and 1 1. So P and Q, will write P and Q first. So this will be 0 0 0 and 1, and then we will take negation of P and Q. So this will be 1 1 1 0, and then negation of P will be 1 1 0 0, and negation of Q will be 1 0 1 0, and then if we take negation of P or negation of Q, it will be 1 0 0 0. Okay, sorry, this is 1. So 1 1 1 1 and 0. Okay, 1 1 1 and 0. So you can see 1 1 1 0 1 1 1 0, these two are same. So that's how we can verify any law, and remember that all the laws are given with respect to and or. So this De Morgan's law is given for or, same way it will be defined for and also. So if it is and here, it will be negation of P or negation of Q. Same way we can verify. We'll draw the truth table for this. We will draw the truth table for this. Both will be same. Then next law is commutative law. It says P or Q is equivalent to Q or P. So anyway, this order does not matter. If I say 0 0 0 1 1 0 1 1, so if I take P or Q, then also I'll get 0 1 1 1, or if I take Q or P, then also I'll get 0 1 1 1. So that is commutative law, and first it is defined for or and then it is defined for and. So all the laws are defined for and or both if I have two propositions. Okay, and then associative law, if it is P or Q or R is equal to P or Q or R, and then this is given for or. So the next the same law will be defined for and as well. And one thing you have to remember in associative law, one thing you have to remember, both the places inside the bracket and outside the bracket I have same symbol. Here also if I have or, I will have or here. If I have and, I will have and here. And same way you can verify associative law also. Draw the truth table for this, draw the truth table for this, both you should get same values. And then next is distributive law. So the difference between associative and distributive: associative, both the places you had same symbol. Distributive, you will have different symbols. So if you have or, here you will have and. If you have and, here you will have or, because all the laws are defined with respect to and or both. So first if it is defined, I mean if P or Q and R is nothing but P and Q or P and R. So P is distributed over Q and R. Okay, and if it is and here, so then it will be or here inside the bracket. So it will be P and Q or P and R. So distributive and associative, that is the main difference. Associative means both the places you'll have same symbol. Distributive means both the places you'll have different symbol. And if you have two propositions, so the law will be defined with respect to and or both. Okay, and then next is idempotent law. Idempotent law, it says P or P is equal to P. So definitely if I say I have P, so it is 0 and 1. Again if I write P, 0 1, so P or P will be what? Definitely it will be 0 0 will be 0 and 1 1 will be 1. So you are getting P only. So this, it is given for or, same way it will be given for and also. So if I take P and P or P or P, it will be P only. Then identity law, P or false is equal to P. So P or false is equal to if I say proposition P is 0 and 1 and then the other input is false, means it is 0 only. So definitely if I have to take OR, so it OR means one of the input is true. So it depends on the value of P only, because this is false. So the output will, it depends on the value of P. If it is true, it will be, if it is true, it will be true. If it is false, it will be false. So this depends, the output depends on the value of P. So this will be P. If I have P and true, so if I have and this value is true, so definitely then also the output depends on the value of P. If it is true, this also will be true. If it is false, this becomes false. So that is identity law. And then inverse law, it says P or negation of P will be true. So we can see P is 0, 0, 1, negation of P will be 1, 0. So if I take OR, P or negation of P, it will be 1 and 1. So this will be always true. But if I take AND, it will be false. Why? Because if I take AND of these two, so AND of these two, because one of the input is false, here also one of the input is false, so it will be false. So that is inverse law. And then domination law, if P or T is equal to T, that means if I have 0, 1 and this value is true, okay, this value is true. So if I have to take OR, definitely it doesn't depend on the value of this, because this value, one of the input is true, so this will be always true. And if I have to take AND, then definitely it depends. If I have to take AND and this is P and false, that means P is 0 and 1 and false means 0, 0. So if one of the value is false, definitely the output will be false only. So that is domination law. Absorption law, P or P and Q is equal to P and P and P or Q is equal to P. So how you can remember? Both the places you have P, here you have OR, so here you should have AND, here if you have AND, you should have OR, and this can be verified using truth table. So draw the truth table for this, draw the truth table for this, both you should get same values. Same way here, draw the truth table for this one and draw the truth table for this, you should get same value. So that's how you can verify absorption law. So hope you have understood the concept and these laws you have understood. Thank you for watching.